Alright, we are now back to the our tutorial where we are going to discuss about the case 2 of vectors resolution. The previous clip talked about the case number 1, which when two vectors acted in different direction, which we tend to find our resultant by subtracting the vectors based on the great and the small one. So in this case we are going to talk about the case number 2, and the case number 2 says when two vectors acted on an object in the same direction, so the resultant vectors will be toward that direction where the two vectors moved on. Assuming we name it to be case number 2. In the case 2 says when two vectors acted on an object in the same direction. In the same direction, the resultant vectors between them is the sum of the two vectors. Now what the case is saying is that the case now says when two vectors acted on an object in the same direction, the resultant vector between them is just the sum of the two vectors in the same direction. Also. In the same direction with the other two individual vectors. That's what it explains about. So let's take this as an example, see how we are going to treat this very case. That when vectors, or when an object is created here, assuming this is the object, the first vector, vector A, and the other vector, vector B, acted in this object. And automatically this is the object, and this is the first vector, this is the second vector, Now the resultant vector between these two vectors is nothing but it's just the other, or it goes this way, which is in the same direction with the first and the second vector. So in this case, there is no any much problem. The resultant vector here will be equal to the vector along the A side plus the vector along the B side. So this is it. When the first vector, assuming vector of A equals to 20 Newton, and the vector along the B equals to 10 Newton, assuming, so the vector resultant will be equal to vector of A plus vector of B, which gives you 20 plus 10, automatically 30 Newton. This is how we get our resolution. Simple. It's just simple and straightforward. This, it doesn't mean when I say vector A plus B, it's all the same by saying vector B plus vector A is all the same. Just like when you see 2 plus 3 equals to 5, you know, also 3 plus 2 will be the same thing as 5. So there is no differences. So that is it. In this case, we don't take any regard on which vector is greater than another. Being small or big is all the same. But mark you, there was something I forgot to tell you. What was that like? When the two vectors, in the case number 1, when two vectors are of the same direction, are of different direction, and they have the same magnitude, meaning the vectors are equal in size and magnitude everywhere, So the resultant there will be equal to 0, because assuming you have a vector A is 20 Newton and the vector B is also 20 Newton and they move in different direction, which is opposite direction. Now the resultant will be just 20 minus 20, which gives you what? 0 Newton. So this is where I forget to let you know, but this is how it is. So vectors moves in different direction, you will subtract one another from to get the resultant. If the vectors are equal, then the resultant will be 0 automatically. But if the vectors are different and they move in the opposite direction, you will have something as the effective vector, which is net vector or resultant vector. Some textbooks or some other places they call it net vector, other places call it resultant vector, and then some other places call it effective vector. It's all the same. Effective, net, and resultant is all the same. It has the same magnitude and direction with the individual vectors acting on the object. So while in the same direction, we don't take care of their magnitude or their size, whatever size. So that is it. Whatever it is, like in this case, we have vector A is 20 Newton as an example given, and the vector B is just 10 Newton. So the effective vector will just be the same thing as 20 plus 10. So the same, simple and straightforward. So this is the case number 2, and wait for me for the case number 3 and number 4. Thank you very much.